Well, hello everybody. We're going to talk about angles of elevation. And an angle of elevation is an angle where you are looking off, if you're following the horizon line, which is this dotted line down here, and you look up to see something, that is an angle of elevation. So this, from the watchtower, angle 1 is an angle of elevation because they're looking up to see the plane. If they were looking down to see the plane, well, that's something else. And when you're looking down from horizontal, so up here with this dotted line, the plane is flying on a horizontal. When it looks down to see the tower, angle 2 is an angle of depression because we're looking down to see something. And that's really what we're talking about. So if it's below the horizontal line, it's depression. If it's above the horizontal line, it's elevation. So let's do an example here. So first thing they want us to do is classify these. So let's talk about elevation first. If we're going to find angles of elevation, we're looking for horizontal lines and we're looking up. All right, so what angles represent angles of elevation? Well, from the mountaintop, I see that angle 4 is an angle of elevation because it's looking up to see the plane. And from the plane flying on the horizontal here to look up to see the helicopter, that would be angle 2. All right, depression angles. Depression angles are looking down, and so as the helicopter is flying across horizontally here, looking down to see the plane, that would be angle 1. Angle 1 is an angle of depression. The plane here to look down at the top of the mountain, that would be angle 3. And so those are my angles of elevation are 2 and 4, and angles of depression are 1 and 3. That's just naming them. So let's try this from a perspective of right triangles and whatnot. So an air traffic controller at an airport sights a plane at an angle of elevation of 37 degrees. The pilot reports the plane's altitude is 6,000 feet. What is the horizontal distance between the plane and the airport? So we've got our tower down here. Got our tower here, and it is looking, it says it's an angle of elevation from the horizontal. And so it is an angle of elevation of 37 degrees. And this distance right here, they told us 6,000 feet above is the plane's altitude. And so they want to know the horizontal distance, which is this side right there. And so they want to find that distance from the plane, which the plane would be up here somewhere. We can draw a plane. So the horizontal distance from the plane would be this x value down here, and so then therefore we would find, that's what we're going to find. So we got to look at what we've got here, and so if you notice from the 37 degrees, I'm going to make this guy is going to be a right angle because distance to the ground is always at a right angle. So if you're looking here, opposite the 37 degrees is this guy, so this guy is the opposite side, and we are trying to find the adjacent side, it looks like, for x. So which trig function uses opposite and adjacent? Well, that's tangent. So the tangent of 37 degrees will equal the opposite over the adjacent, and that adjacent is the horizontal distance, so we should know how to solve this guy. To solve this guy, I'm going to flip-flop these places, so x will equal 6,000 divided by the tangent of 37, and if I then calculate this, we would get that 6,000 divided by the tangent of 37 will come out to be 7,962 feet, and then it's 0.268 here. So it says round to the nearest foot, so the horizontal distance would be 7,962 feet. All right, and that's what we're looking for at that moment in time. All right, so then here we are at a ranger station, and the ranger station, it says the ranger is in a 70-foot tower, sees a fire at an angle of depression of 9 degrees. What is the horizontal distance between the tower and the fire? Well, we see this angle of depression going down, and you may notice that this guy over here is 70 feet. That's what they told us. It's a 70-foot tower. And so we're trying to find x down here. Well, if this is 9, what is this angle over here must be 90 minus 9, or 81 degrees. And if that's 81 degrees, this guy is 9 degrees. Now you may recognize this right here, that if the horizontal distance to the ground are parallel, then we have alternate interior angles, so these two angles would be congruent. Now, in knowing that this guy's 9 and this one's 81, you can use whichever trig function. You can use the trig function of opposite and adjacent, or opposite and adjacent, to find the missing angle. So if I'm going to find this, I'm going to use the 9 degrees over here because that's kind of what they told me. And so 70 feet is opposite, where x becomes the adjacent, and the triangle that uses opposite and adjacent, well, that's tangent. And you will see, as we do a lot of these problems, that tangent is the one that you're probably going to use the most, because most of the time you don't know the hypotenuse distance, because that's as the crow flies or whatever. So if I have tangent of 9 degrees, that is going to be my opposite of 70 divided by x over my adjacent. Again, we're just like the previous problem, we're going to flip-flop these places. 70 divided by the tangent of 9, that will kick out the horizontal distance. And when I calculate that, that gives me that my horizontal distance to the nearest whole foot is 442 feet. All right, so thank you.